Okay. So good morning, everybody. This is the virtual session of the Civil Engineering Department Open House for Engineering 1 students. We had the in-person session 2 days ago, and this is the virtual session for 1 hour. I would like to welcome Dr. Bing Houdler, Biebel Houdler, head of the Civil Engineering Department, and I welcome also Dr. Steve Bruno, Director of the Industrial Outreach and Associate Professor in the department. Without losing much time, I would like to welcome Dr. Biebel Houdler to give a short speech to welcome the students.
Good morning, everybody. Do you hear me?
Yeah.
Well,
yeah.
Okay, that's good. All right. Good morning. So my name is Bepul Howlader. I am a professor in the Faculty of Engineering in Civil Engineering Department, and I am the head of the department. Thank you for coming to this open house. And I would like to say a few words and why you might like to choose the civil engineering. So maybe I should start with some of my personal experience. The personal experience is very important. You see that if I am not happy with civil engineering, so how can I encourage someone to come to civil engineering? So I would start with some personal experience. So now you are at a stage now you have to decide that what you are going to do and what you are going to study. So like I had that situation about 36 years ago. So I had to decide that what I am going to study. So initially I started with medicine, and then after 1 month I quit that one and I came to engineering, and that was easy because I liked engineering compared to medicine, so that was easy. But when I came to civil engineering, so I had to decide that why I am going to civil engineering. So the main reason why I wanted to be civil engineer was that I wanted to do something that I can see. And although at that stage I didn't have much experience about all kind of things what civil engineers do, but with time working so many years in industry and research center and university, I found that, well, civil engineering has many more things that we can we like to do. So I'll give you some highlight some of the things that you might consider to why you can choose civil engineering. First, at this stage you may not know that, okay, so if I pick civil engineering, whether I will continue and whether my life is going to be narrow in one area. So no, it is not. The civil engineering is the area where you have wide range of places where you can work. So if you choose now civil engineering, maybe in future you might like to how you can do it. So at MAN or any civil engineering program, we have we teach a wide range of subjects. So at MAN we have an amazing program, and our civil engineering program is one of the oldest program. So although you know that our main goal is to train the student and make them technically sound, and that one we are going to do through different courses and also giving work experience and through our work term and so on. So we have a diverse group of knowledgeable and renowned professors in civil engineering. So starting from environmental, geotechnical, hydrotechnical, or ocean engineering. So if your interest is to become environmental engineer, or you want to work on global warming, you can select that path. Or if you want to design a large structure, like the Confederation building or Hibernia platform, yes, we will train you for that. So, or you might like to work on mining or offshore or building large dikes like Muskrat Fall. Uh, you, so you will have a number of courses, and we will train in this area, and you will be ready for those kind of jobs. So what I am trying to say that you will have a wide range of sectors where you can have job opportunity in future. So the next thing I want to mention is that civil engineers is the leader. So not only that, see that the civil engineers play the key role in any project. So therefore, in addition to technical confidence, we help the student to develop soft skills in many different ways, and which is also equally important, such as students are given opportunities to work in a group, as in the capstone project. We also train them how to communicate with client and develop idea, solve problem, and also work with a diverse group of people in projects and in work terms. So another thing I think that most of the engineering students like to do is that they want to get some hands-on training. So because we like to build something, right? So we have a that excellent facilities to give the hands-on training. We have our lab is well equipped, and some of the equipments are very advanced and compared to many Canadian universities. For example, if you could get a chance, you can go to our civil engineering lab, and you will see that this is very that we have very advanced testing facilities. And there are also some bigger facilities. Like if you go to the next door, you might see that there is CCOR, and we have a world-class centrifuge center. Although you may not know what is centrifuge center and what does it do, but it is very interesting testing technique. And you will see that his name is Jack Clark Centrifuge Center. And who knows, you guys maybe one day will be one of the Jack Clark. And the last thing I want to highlight is that that these days you is like to develop some computer skills. So and we also train our students with those kind of things. Like for example, these days when we are designing something and we do the analysis, we use the computer software, and we train the students such a way that when they go to the industry, they will know, at least they will have some basic idea about those computer softwares. So then they can use those experience for the industry. So in summary, I would say that this is a program where it's not in a narrow area. Rather, you will have a wide range of areas where you can work. You can decide in future. You can you can pick, if you want to do something, save the environment. Yes, we have that. If you want to be a consultant, you could be like that. And if you want to be a businessman, sure, you can do that on too. So considering that, and from my experience, and as I am happy with the civil engineering, so I strongly encourage you guys to come to civil engineering, and I can assure that you will enjoy this program. Thank you.
Thank you very much, Dr. Haudler. I would like to welcome Dr. Helen Jang, who joined us short before Dr. Haudler started his speech. So, good morning, Helen. Uh, uh, I would like to introduce or invite Dr. Stephen Bruno to deliver a presentation, informative presentation about the civil engineering discipline. So, Steve, it is your time.
Well, thank you very much. And I just am wondering, can you folks see my shared screen and also see me?
Yes.
Yes.
Yeah, you can. All right. So Daniel, Maheen, Tala, Nicholas, Mohammed, I can't see you, but I'm hoping that you're there. And I welcome you, if you feel comfortable, I really do welcome you to turn your cameras on, because I want to be able to, you know, interact with you a little bit and communicate some of these things and answer questions, because you folks are here trying to make a difficult decision about what discipline you want to take. And it's there may be something niggling away at you that we don't manage to hit on with our presentations and talks. So please do flick on those cameras and be prepared to chat or ask questions as we go along. No pressure here, folks. And if you elect to not do civil engineering and you're heading off to a different discipline, we won't be crushed. We will be taking notes. We will notify your families, but no. We're here to try to help you make the right choice, because really we don't want to try and convince or talk people into doing a discipline that they're ill-suited for, or they don't have a fire in their belly about. It's mostly information for those people who are genuinely uncertain and don't really know what each of the disciplines do or what they are. And so I welcome Helen and Beeple or Nuri, if you're going to be staying to interrupt me as I make flaws, or if you want to add something to this talk as I go. But students, I've got a little structured talk here, and what I want to do is answer some of these questions that you might have, and that is having difficulty deciding what should I do, which is really the principal question. And then we have what is civil engineering, to sort of give a little intro about what civil is, and at least the different types of engineering that you do in civil engineering. What does the program actually look like here at MUN? What's expected of you, how long it is, and where you go, and that sort of thing. What are work and job prospects like for civils, and also to encourage you to reach out and ask, right? So, with having said that, are there any questions coming from any of you folks right now before we sort of get started? And I welcome them. Very shy bunch. When we did this last year, there was only a couple of folks like yourselves, and one of them was a young fellow who was, curious, and he asked questions. I hired him for his next work term. We're looking for people who are keen and interested, and we've got lots of work opportunities as well. So don't be shy. At this point, you need to speak up. So I'm going to introduce you to something that you can go off to and look at sometime at your own leisure, and that is that the University of Waterloo has generously provided this engineering compatibility tool. It's just a little Q&A thing that's an online, protocol. You go in there, you start the quiz, and you go and answer these questions, and at the end it tells you you should be a rocket scientist, or you should run away from engineering, or you should be a civil, or whatever the case may be. So it's an interesting little thing, and harmless. Perhaps it can play some role in giving you some identification. So that's kind of what the screenshot looks like of the starting page for it. But I'm sure if you just put in Waterloo engineering compatibility tool or selection, you've got it. So I won't even burden you with an address here. I do have this video queued up, and it's because I think it's a very good one. This fellow talks about 3 principal things that you should consider at your stage while you're deciding what to do. And I'm going to turn it on, and I'm going to just see if you can hear it clearly.
Talk engineering passion so you can get your head on straight.
Can you hear? Do I get a thumbs up? Can you hear it okay?
Yes, we hear.
Not-
Yeah.
If I was to mute.
What's up, everyone? This is Joe Voorhees, and you're watching episode 13 of the 1%.
Not clear, Steve.
Engineering. So today I'm going to give you 3 things to think about so you know you're pursuing your dreams. First of all, I'm going to deny one assumption right away. Many believe they should pursue a certain field of engineering because one makes more money than the other. Throw that out. It's total garbage. They all do super well. You're not going to be happy if you find yourself in a field that you're not absolutely passionate about. So that's definitely the priority. Plus, even if you must shift your focus within engineering, proven that you're an intelligent person, you've succeeded in one field of engineering, and generally they can cross-apply, so someone will give you a shot if you have an engineering degree, or if you've built up career expertise in a certain field and need to apply it to another. So tip number 1, stop worrying. It's going to be fine. You're an engineer, you already won. Tip number 2 about finding an engineering passion is become retrospective. What I mean is this: you should look back on everything in your life that you have enjoyed, you've liked, been passionate about, had interest in. Look at the sports that you played, the hobbies that you pursued, how you spent your time, the books that you read, the movies you watched. What do you like? What are you interested in? What makes you tick? What gets you excited? So I'll use myself for an example. I had a few ant colonies growing up. I was a big-time gamer. I played SimCity and other RTS-type games. And I dreamed of this world where my SimCity would actually work like my ant colony. Everything would work together. You guys know how ant colonies work. It's one big team. These ants can actually do amazing things when they all work in unison, in harmony. They help each other. They can build insane structures and operate as one. They build bridges with all the ants just linking up and helping each other. It's nuts. So I knew about driverless vehicles when I was a kid. I believed that one day all of these things would accelerate in a platoon together. I believe that everything will be connected. Computers will be controlling everything. You would take the entire human element out of it. And that's what we see today. It's happening. It's coming true. My dream came true. And I wanted my career to be in that. ITS, Intelligent Transportation System. And that came true as well. I work with drones. I work with big data. I work with models that are trying to guess what's going to happen in 50 years, even though we have no idea. But my desire to have a career in intelligent transportation systems and work in that field because it excited me. It happened. It happened for me because that's what I pushed in undergrad. I went to grad school in this focus. I got a job in this focus, and I've just continued on this road. It's a very niche type of civil engineering. So that's what you need to do as well. You need to figure out what you like. Stars. Tip number 3, ensure a technological focus. Just like I've already alluded to, my career has been in bed with technology. I think that's very important for you to think about. AI, robotics, big data, space aspects, biotechnology, nanotechnology. These are things that are amazing right now, and they will only become more incredible as the future goes on. You know they have a bright future. Go out there and look at things for inspiration. I encourage Foundation, the Visioneers Summit. These are multinational engineering challenges where the biggest companies and organizations around the world compete to change the world. They work on things like world hunger and clean water and space technologies and all this stuff that will certainly get you excited about the future. Certainly get you excited about potential things in your career. Don't forget about the standard companies that are leading the charge in technological focus. Google, Amazon, SpaceX, Tesla. These companies are all pushing the ceiling higher for what we can do as engineers, what our world is capable of, and what's tomorrow. Pay attention to what they're doing because it really is amazing. These companies are changing things. Very important that you feel excited about this stuff. If you're not excited about what you're doing in your career, you're going to be bored. And bored every day is a good way to hate your job. And if you hate your job, you will hate your life. And everything goes wrong if you don't like what you're doing. So in summary today, guys, look back in your life, figure out everything that you enjoy, figure out what you are passionate about, what makes you tick, what you're excited about, what you love right now, because it's probably an indicator of what you will love later in life. Even if you don't get it exactly right, you can pivot and jump around. It's okay. Stay tuned for episode 14 where we hit.
All right. Um, I hope that that was interesting. This fellow has captured a couple of key points here, and that is that sometimes when you're trying to decide what it is that you're going to pursue and what discipline you're going to do, don't ignore your gut feelings and instincts, even if it doesn't appear to be some rational basis for it. You just feel like it's something you like or you want to do. That's okay. You know, you shouldn't be doing one or the other because somebody told you that that's what you should do, or because you think it's going to be, you know, worth more money or whatever the case is. This person is right that you'll have a better life if you pursue those things that are of interest to you and are near to you. So, having said that, why don't we get closer to describing what it is that you can do in civil engineering to see if that matches you? But for your interest, last year I asked students who were in their final semester of civil engineering what message they would send to the first years, Eng ones, about why they did civil and what would the message be for them. And there's some pretty funny responses here. Although someone says there's always work for civils, they're absolutely right. You know, civil engineers are for sure the discipline of engineering that is most international and broadly accepted. It covers all languages everywhere in the world. Needs things such as this: civil jobs are always needed. The toilet always needs to flush. Um, you know, we don't all become hydrotechnical or municipal engineers. We embrace complex software development, many aspects of environmental mitigation and environmental works. There's a lot of folks studying climate change, et cetera. But still, some of the fundamentals, the transportation, structure, and water delivery, these are so fundamental to society. We take them into for granted these days. It's not until a very rare occurrence happens when either a severe storm meteorological event or a bridge collapses due to poor maintenance or a failed design or something that you learn about it. Otherwise, billions of people go about every day crossing roads, bridges, and getting into buildings that they just inherently trust. But that's on the backs of our ancestors and us here today to make sure that that trust continues and that we get better at it. And again, it's all about efficiency. So anyway, here's some of the funny responses. I hated programming, love 1030 and 1010 in Eng 1. Well, I mean, that's someone's opinion of why they went into civil. I do think that Newfoundland civil is the most diverse. The Shanghai Tower, Three Gorges Dam, Brooklyn Bridge. You don't have to go far to look for inspirational civil engineering structures. The Eiffel Tower is a beautiful structure, architecturally beautiful, structurally very interesting. And Gustav Eiffel was himself a civil engineer and world renowned. And we thank him for that. Okay, so these all seem so cliche, oh, the Eiffel Tower. It's like, every lampshade has a picture on it, or you go to Walmart to buy a picture frame and it's got the Eiffel Tower in it as a substitute for a family face or something. So it's become almost ubiquitous and forgotten. Well, there's a reason for it. It's really cool. And don't forget that these things are interesting and fun to look at. A number of these things, the Three Gorges Dam is an example of a project that is just astronomical in its scale, but civil engineering undertakings like that always have unintended side effects and spin-off problems and issues that are a problem that need to be mitigated and solved. And it's our duty going forward to figure out ways of increasing the well-being and welfare of our society, while at the same time not trampling nature and its cycles, but elevating it. And it's been a long struggle for centuries to get us to the point where we now have the luxury of doing things to mitigate environmental problems, atmospheric, CO2 levels, and all these sorts of things. These, 100 years ago, people were struggling to get the economies going to be able to get standards of living up to a decent place. We're there now, notwithstanding many problems in the world of inequities and stuff, but we're there. We now have the abilities, and we study ways to not just build a building, but how to do it with the best overall efficiency, minimal impacts, perhaps improvements to the environment. So keep that in mind, that civil engineering is in fact the solution. Any thoughts or questions before I carry on there from Mohammed, Tala, Maeen, Ahmad, Nick, Daniel, Nori, Beeple, Helen? We're all in the class together.
I request I request the student to ask the question. It doesn't matter. It might be very simple question. You know what? When I started my career, I had all those simple questions. Now you might think it is silly. I should not ask that question, but this is real. We understand that when you are coming here, you have no idea that what we are going to do. I can tell you that even for a couple of years ago, one student in term 5, she came to me and she said that, well, Dr. Halodar, what does actually geotechnical engineers do? So you could have those kind of question. It's the thing. Please feel free, right?
Yeah.
Dr. Bruno can answer those questions, right?
Oh dear. Okay. Well, one question, I'm not sure, but one thing that I tried to explain on Tuesday, and I don't know if I probably didn't do a very good job, but I'll say it again, and that is that from my own experience. So I have 2 children who both went through our engineering program here. Oftentimes, the questions that students would have is like they like to do a certain type of engineering or thing, like they're good at computer work, or they're best in an office, or students who are definitely outdoorsy field people, or you're a sports person and you just can't bear the thought of graduating from university and spending the rest of your life in a cubicle. You'd really rather be out in the field doing stuff or to explore. So here's a few thoughts on this. First of all, no job that you choose will ever satisfy all of the interests that you may have. You need to choose a career that's going to give you the latitude and the ability to do some of your hobbies and things in your spare time. And it's not necessary for you, if you really are impassioned and enjoy music, for instance, that's an excellent pursuit and a great interest. But you don't have to worry about, you don't necessarily have to go to the School of Music and study it. You might be better suited, if you have the abilities and capabilities of becoming an engineer and pursuing music as a sideline gig or opportunity. You have the freedom to do it because you have some security of your income. Unfortunately, in our society, it's very difficult to achieve that as a musician. So what I want to say, it doesn't have to be an either or. Many of the interests, whether it's writing a book, or I'm not sure if I should be in engineering because I'm impassioned about doing international development work and volunteerism. Maybe I should pursue something else there. Well, check that, because having a civil engineering degree is probably the best possible start to your careers and lives, because above all, it just teaches you how to solve problems. It teaches you how to think and solve things in a rational way. And that goes for pretty well all the disciplines, but I think that civil probably equips you better for a very worldly perspective to pursue those things. In addition, you can choose any discipline you want, be it mechanical, civil, electrical, whatever, and be a computer person or a field person or a consultant on your own or a part of a big company. So if you're confusing the choice of discipline with the kind of location and type of work you're going to do, whether it's work for yourself or work for a big company, work for government or work for whatever. That doesn't actually matter because you can do all of those things within every discipline. So you don't need to worry about choosing the right discipline in order to make sure that you get to do a lot of field work and you don't have a cubicle kind of thing, because you can do that within each. So the subdisciplines of civil engineering that we all recognize here, and each of us have our own specializations. Structural engineering, very broad based, and then transportation engineering, geomatics. Each of these, I've got a slide or two to follow to sort of, fill in some of the blanks.
Steve, sorry, Steve.
Yep.
Mohammed asked a question.
Oh, I don't have the,
Okay.
Unfortunately,
Okay.
the.
Mohammed, he asked a question. How do the course offering for the first year civil engineering look like? So, do you want to answer, or I can?
No, you go ahead. This is, I take it that he means term 3,
right,
term 3 and 4.
Okay.
What do those
Okay.
look like? Yeah, go for it, people.
Okay, Mohammed, that's a very good question actually. You see that when you are coming to civil engineering program, we try to introduce what is civil engineering, and that slowly we are going to bring all the students to the higher level. That's what we are doing. So if you start when you are coming to term 3, so we are you will have a course like materials of construction. So definitely you need to know that what kind of material you are going to use, surveying and geometrics. So you understand that if you want to build a highway or a building or anything, so you need to do the surveying. So those kind of things we are going to have. Then you have earth science in civil engineering. And also we will have one course on mathematics, because you know that engineering you need math course. So those kind of courses you will have. And then we will move to the term 4, and we will have the next level of courses like mechanics of, then we will have, we should go to term 4, and then you will have the mechanics of solid, environmental engineering, geotechnical engineering, the first course on geotechnical engineering, and mathematics for civil engineering. So this is how we are going to move. Even you are going to learn engineering economics, right? So this is how slowly we are going to bring you to the higher level.
Mm-hmm. Thanks, Bipul. And that question sort of precipitates another point that I like to make to students to keep in their minds, and that is that oftentimes it seems appropriate or even quite responsible if, while you're at the stage you're at right now, to choose a subdiscipline and to target that subdiscipline. For instance, if we offered Bachelor of Civil Engineering with a subscript, oil and gas, or a subscript for hydropower engineering or something like that, it sounds cool. You want that on your resume and whatnot. But what we know from having our co-op program and our interactions with clients who are the employers of the world, what we know is that employers are more attracted, are just as interested or more so in having a student who has a broad-based general degree in civil engineering, somebody who has the width of background and the basis upon which to build, because it's acknowledged that you're not going to learn the sort of detailed knowledge that you're going to need within each of these professions. You don't learn that until you get to the workplace, and they can mentor that, and it's obviously known. If we in our school here try to achieve a level of sort of operational knowledge for each of these sub-industries and embed it in our program, we'd be removing something else from your education that is needed in the long term. It allows you for greater flexibility through your life as well, so that if you subspecialized, it was very popular not long ago to subspecialize in the oil and gas industry. This is much less so. It's not an industry that's by any means dead, and it isn't one that pays poorly or any of those things, but the excitement and enthusiasm has certainly diminished from what it was a decade ago, largely because people see the longer term future in renewables and whatnot, and perhaps rightly so. People are concerned about about the environment and climate change and that sort of thing. So anyway, the point being that how do we know right now what the future holds? We're better off giving you a broad-based education and trying to give you a couple courses in geotech, a couple courses in structures, a couple in transportation, a couple in the environmental areas, and hydrotechnical and that sort of thing, which is what our program does. So that is a long answer to your question. Some of the others I just mentioned: geotechnical, construction, water resource, sustainability, urban planning, coastal and ocean engineering, sort of a subset of a couple of different ones here. So these are some of the topics. I'm not going to spend much time on every slide in this. Just some inspirational shots. A very cool looking a canal. This is a canal in Scotland, and boats pull into this canal and it swings around and then the boat can leave. So this is a lock, but not a traditional lock kind of a thing, and a very cool looking structure. Just look at this this multi-level exchange tucked in amongst all of these blocks in Shanghai. Just an astonishing amount of engineering that goes into there. 1, 2, 3, 4 or 5 layers of that is complex. It's hard to appreciate sitting here how much software, how complex the software needs to be to come up with something like this and develop it. That software can't be developed by software engineers alone. It needs people who are civil engineers to understand what, all of the slopes and the loads and strengths and various things are. So very, very complex system. Newfoundland Labrador has a terrific tradition of large civil engineering undertakings that are very successful. And here is a picture of the Upper Churchill Power Plant, which was, when it was built, the largest subterranean power plant in the world. Almost 6,000 megawatts of power installed there. The entire powerhouse is excavated. It's underground in a rock tunnel that was excavated for this project. It was developed, the whole thing, along with its 100+ dikes and dam systems and whatnot, in Labrador. It was developed remarkably ahead of schedule, under budget, and it has operated practically flawlessly for 50 years. It is just a fabulous testimony to excellent engineering work. Unfortunately, the context that you hear it in is always a political one, and are we getting ripped off from rates and all that stuff? Well, just putting that aside, the economics for a moment, the actual installation and the planning was phenomenal. And here's another. Like it or hate it, the oil and gas industry has had a profoundly positive impact on the economy and welfare of people in this province. And this was the biggest investment. This is the Hibernia offshore oil and gas platform. And it is a gravity-based structure. It sits on the seabed. The seabed is 80 meters deep at this location. This, to give you some context, this base across here is about 100 meters. So it's not as deep as this structure is wide. It's fairly shallow. But this massive piece of infrastructure is comprised of an unbelievable number of structural elements and concrete. It's designed for loading that was not seen or conceived of anywhere else in the world. Very significant wave loading, very significant ice and iceberg impact loading, unbelievable wind conditions. Corrosion in this environment is astonishing. So it sits out there and makes billions of dollars for its owners and us in this province. And we should be very grateful for the safe and operation of it, and for the excellent engineering design work that went into it. I had the opportunity to work as a civil engineer. I worked at the Wind Tunnel Lab while I was doing a master's degree. in aeronautical engineering, this ended up being one of my projects, was to help construct a model and do wind tunnel tests of the helicopter pad, the airflow around the top sides for natural ventilation and for air quality where the helicopters were going to land. So we moved the helicopter pad all over the place. And the initial design actually called for 2 helicopter pads on this platform to ensure that there would be safe landing no matter what direction the wind was blowing. But in any event, they ended up with one and it's worked out perfectly. The CSCE is the Canadian Society for Civil Engineering. You can be forgiven for being confused with all of these different societies and associations. There's really only one main association that you need to be concerned with as you go through your career, and that is the Professional Engineering Association of each province, which regulates, ensures, polices the engineering profession. And in Newfoundland, it's PEGNL, Professional Engineers, Geoscientists, Newfoundland, Labrador. It is an association established by legislation. It's a legal overseeing group, and that's what keeps engineers in line. Just the same as medical doctors are members of the medical association. That association polices and makes sure that people are performing at standards that are acceptable, et cetera. It's not an advocating firm. It's not a social organization. These professional organizations were established by law. On the other hand, when you look at the Canadian Society of Civil Engineering and other societies like that, these are more or less clubs, a club for that type of engineering. And in civil engineering, this is it. Now, last presentation, I put my foot in my mouth by telling folks that the CSCE hasn't been able to do much for us here, and yet they have been doing more things than I was really aware of. But what I can say is that it's a bit challenging for us because the way our engineering program is split, we have Society A and Society B. All of you folks go into term 3. At the very time that you go into term 3, there's a group of students who are going on work terms. And then when you go on your work terms, there's a group of students who are in. So we always have a duality, a small number of students in each society, and it sort of breaks it up and makes it a bit challenging. But nonetheless, these folks, the CSCE, sponsor national conferences and competitions that you can be involved in as students. And we try and encourage that and provide some support and funding for students who join the CSCE, although I think student membership is free. But we try to encourage some of these activities, right? So there's the CSCE. Closer look at types of civil engineering. Well, I guess I've sort of spoken about each of these a little. I think I'll go through them a little quicker here, but structural engineering, who wasn't impressed as a kid with these, massive suspension bridges or skyscrapers and seeing them in place? That it is impressive. It's not so much that this is the great conquest of nature as much as it is elegant and efficient and safe design. And here is a sculpture of sorts that Nouri can speak more to. Just an amazing looking piece of infrastructure. Look at the infrastructure inside of this half dome. I mean, just fabulous engineering. I believe, Nouri, you said on an artificial island. So civil engineers have.
Yes, this is an artificial island, and there is a museum underneath the sculpture. So,
Where is it?
Baghdad, Iraq.
That's in Baghdad. Well, God bless it. And Nouri, I think that was your homeland. Is that right?
Yes.
Beautiful piece of engineering. Did you have a hand in that, by the way?
No, by then I was a high schooler.
Yeah. All right. Transportation engineering, folks. In Canada, well, everywhere transportation engineering is a big deal, but we've got an awful lot of transportation needs. The province of Newfoundland has, we did away with rail some years ago, which was unfortunate, I suppose, but it never made any money. So, but we sure do need improvements in our highway systems, and for sure our airports are good, landing systems. There's, when you think of air, sea, the port construction of ports and marinas and these sorts of things, they're all very much a part of our civil engineering culture. And I teach a course right now in coastal and ocean engineering, and the students are in term 8 doing this. Every one of those students is designing a new marina. And in this case, it's a marina for the town of Brigus, just outside of town. These students, those who sign their a waiver, will be presenting these projects, providing these projects to the town, so the town can use them in consideration for money applications for building said marina. So we choose a new location every year, a different one for a different town, with the hopes that we can assist these towns in realizing these new pieces of infrastructure. Oh, look here. I mean, Pearson International Airport. This is, I think we call it Turmoil 3, as opposed to Terminal 3. It's just a huge. These are really interesting undertake. Transportation engineering is really tough because it's a similar situation to what doctors face when they operate on a patient. Doctors can't turn the patient off, take the heart out, put another heart back in again, and start the patient up again. You have to keep it going. Like a mechanic on a car, you can take the engine out, do some work on it, put it back in, whatever. But you can't do that with the car still running. That's the difference between a mechanic and a surgeon, is that the car, if a mechanic had to do everything on the engine, but the engine had to continuously run, then that would be more akin to what mechanical or what doctors have to do. In the same way, that's what civil engineers have to do in their design work when they're working with transportation systems. Usually, you can't afford to stop the system while you're doing all this work. So it leads a lot of things like the construction of new bridges and overpasses is being led nowadays by design and planning work that involves minimizing the downtime. And I've seen a number of different bridges being constructed in the Ottawa area where a new overpass is being installed. They can't afford to shut a highway down. So they basically construct the whole thing adjacent to where it's going to go. And in one night, do a huge big old swap over, and all this equipment is there and the highway is shut for, 12 hours and boom, the new bridge is in place. So this is really quite a remarkable thing. It's like defusing a bomb or something. You really have to be cautious. Time is of the essence. Geomatics and surveying is critically important in civil engineering. Always has been, and it will continue to be. The tools keep improving and changing, and you fortunately, as students, you get to go out and survey Prince Philip Parkway and the north side of the campus.
Dr.
as if
Bruno,
it hasn't been.
probably Dr. Jan can talk to the environmental engineering, as her teaching and research is environmental engineering.
Thank you. Yeah, why don't I do that? Helen, please, why don't you have a moment here with the students?
Sure. So I just briefly introduce a bit about the environmental engineering. As stated here in the slides, the environmental engineers try to improve and maintain our environment to protect and help, and enhance the human health. For example, during our daily life, we need clean water, drinking water. So we have the drinking water treatment plant. We need to treat our sewage wastewater treatment plant. So we need every day we collect the household solid waste. So we have municipal solid waste treatment systems, multiple technologies. So all of those are part of the environmental engineering to help us to run our systems, to help us to maintain our daily lives, the quality of the life. So here you can find We have the St. John's wastewater treatment plant. This is Riverhead wastewater treatment plant. So I believe if you join the civil in our courses, we will have a chance to visit all our like wastewater treatment plant, drinking water treatment plant. So we will see all the part of it. And meanwhile, I would like to, say a bit. Other than that, environmental engineers taking care of all types of projects to treat, the all sources of contaminants. For example, if we have contaminants exist in the subsurface, in the soil and groundwater, so we will have technologies to conduct site remediation. This is part of our environmental engineering. And in Canada, about like over 60% of the environmental industries like taking care of the site remediation project. This is a very big section. We have a lot of problems, all types of contaminants due to the historical reason appeared in the subsurface. And we also have emerging contaminants. You all know that we have climate change, why we talk about the reduction of carbon dioxide from all aspects. We try to, find the solutions to try to, keep our current qualities of life to protect for the future, and also emerging contaminants like we talk about the plastic pollutions, usage of plastic every day. It become such a big issues. So every day people use products, and those most of them are chemicals, and granularly we find that there are some problems. So we need techniques, methods, we need people, professionals to deal with all those emerging issues, and those are all the our environmental engineers' job. So there's a lot of interesting things, and hope I have a chance to in the future, the few years, we will have a chance to teach courses and to exchange ideas with you guys. Thank you. And this is our lab, one of our labs. We will have lab sessions for the both undergraduate and graduate levels in environmental engineering. Thank you.
Excellent. And thank you, Dr. Helen, very much for that. And I am sort of jumping around a little to try and accommodate what folks are saying, but I won't take much longer now because our time is getting close. I think we've each had a bit of a chance to talk to this, except perhaps Dr. Nouri, you who are hosting this meeting may want to say a few things on the work that you do.
Thank you very much. I do environmental engineering, probably a new phase of civil engineering job. I work with livestock waste, with farm waste, with agriculture waste. So don't be surprised if I tell you that I spent about 5 years at Agriculture Canada working on dairy manure, on cow dung. Before that, I spent 5 years working at Faculty of Medicine to teach medical doctors how do they take care of waste, what is the relationship between waste and hygiene, etc. So what I want to say here, probably for people looking at the civil engineering from outside, they don't really know the breadth and the scope and the potential of civil engineers. You can find civil engineers everywhere. You go now to the hospital, probably you'll find 1-2 civil engineers taking care of the ongoing maintenance year-round. You go to a power plant, still they have civil engineers. You go to transportation system, they have so many civil engineers. So don't underestimate the potential of civil engineering. Regardless what you will be specialized in, the opportunity, the scope, the jobs are there all the time. I believe Canada needs, as of now, about 25,000 more engineers to take over jobs available in the next 20-25 years. This is from the civil engineering market prospect. So I would stop here and leave if some minutes if the students have any questions. Thank you very much, Dr. Pascal.
Excellent, thank you. And I have a few slides you can see just gone through the others there because yeah.
Talaha has a question that how competitive is civil engineering at MON?
Okay, Well, I'm not sure exactly, Tala, if what you mean by that is how competitive is civil with respect to other civil engineering schools, or to get into when you're going from Eng 1 into term 3, or when you're within the civil engineering, how competitive is it amongst candidates? Can you clarify if you mean, oh, to get into? Well, that's a good question. Bipul can perhaps answer that better.
Um, okay, it's a very good question. I do not have all those data right now, all those numbers. Like, I believe, Tala, you mean that the
You can
about
choose civil,
marks, right?
yeah, if the students choose civil as their first choice, are they going to get in there if they have a 75 average or something? That kind of
Yeah,
question.
something like that. So that is not exactly, I cannot give you the average exactly what you need. That is not, I know that I cannot give you that answer right now. However, if you need, you can come and you can talk to me later.
Well, I'd like to say that it isn't very competitive to get into at the moment, because we've gone through phases. All the disciplines go through cycles where the class size increases and decreases. We've got civil classes that have had like 29 graduates, and then civil classes that have had 50, 60 graduates in it. So we've had great fluctuation, Tala. And we can't always tell from one year to the next what it's going to be. But my inkling is that it is not going to be as difficult to get into civil as, for instance, computer engineering, which has become very popular for fairly obvious reasons. So usually it's not too bad. People get their choice. And I don't know what the grade, what your average needs to be to get in, because that's something that is every year changing. But it's not, if you're in the middle of the pack of the students in terms of your grades getting into term 3, I don't think you have any problem getting into civil engineering. We have seats, the capacity, basically 60 people to come into engineering, and our classes are not that size right now. I'd love to say that you can't get in because we're all too smart, right? No, I wouldn't love to say that, but the fact of the matter is there's room and we welcome them. We want you folks to join civil because we're happy to have more in our class. It helps make life richer, and I think that it's an excellent choice. In terms of getting jobs, you can be a private sector employee like a contractor or consultant. Public sector, there's a lot of, probably more civil engineers than any other profession that works for government, because of the amount of money that's spent on infrastructure, transportation, bridges, city sewers and water systems and all this sort of stuff. Of course, there's research and academia. If you're particularly interested in teaching, an engineering degree is an excellent background for school teachers. And of course, you can carry on into the research sector and get into the universities as well, and project management, consultant, marketing, etc. I mentioned Paganel, that's the Professional Engineering Association. And I think I would like to close my talk right there. Our time has just expired, I think, or mine has. And so I'll leave it there. But again, welcome questions to any and all of us from you folks. And I hand it back to Dr. Nouri.
Thank you very much, Dr. Bruno. Any question? Since we are, exceeded the time, so I don't want to keep the students long. Any question, please? If you don't have your question ready right now, feel free to email us. Any of us available here, Dr. Haudler, Dr. Bruno, Dr. Jang, or myself. Or also you can email any faculty in civil engineering to get your question answered. Anytime we are available to respond to you. If no questions so far, thank you very much for your attendance. We appreciate it. Thank you very much, Dr. Haudler, Dr. Bruno, and Dr. Jang for attending and delivering the presentations. Thank you very much.
Thank you.
Thank you, Nuri. Good job.
Bye.
Thanks. Great. Bye.
Take care. Take care. Bye.
Okay. Thank you.